My name is Mike Schwarz and I'm the Managing Director of iTech Minerals. Today I'd like to talk to you about our most recent results from our Campoona Spherical Graphite Project. We've just received the final results from our metallurgical test work program, which was undertaken with a company called Anzaplan in Germany. And the aim of that program was to produce battery-grade spherical graphite for use in the negative terminals or the anodes of lithium-ion batteries. And I'm pleased to announce that that program has been very successful, and we've been able to produce a battery-grade spherical graphite which meets all of the relevant battery parameters and criteria. So the most recent results that we've just received are for the spheronization and the purification stages. Anzaplan were able to produce both a high purity flake product and a high purity spheronized product. So flake normally gets converted into spherical graphite for use in the anodes of lithium-ion batteries, and they were able to convert 47% of the flake product into a spherical graphite. And then we did a whole lot of tests on that spherical graphite to see whether it would be suitable for use in the negative terminals or anodes of lithium-ion batteries. And there are a whole lot of different parameters that they test. First is purity. You can see the fixed carbon percent was able to be achieved at 99.99%, so well above the 99.95, which is the industry standard. Yield tests in China, generally they convert 20 to 30%. We were able to convert 47%, which has obvious economic benefits, being able to convert more of your material to a high value product. Tap density, that generally has to be above 0.9. We achieved 0.94. So what that means, tap density, is how much of those spherical graphite granules you can fit into any given area. So the more graphite you can fit into your anode or negative terminal, the higher the energy density that you can achieve. So that is a very good tap density as well. Now the D50, that is your average size of those spherical graphite grains. We achieved an average size of 17.2 microns, and for a medium-sized product, which generally goes into energy storage batteries and also the batteries used in electric vehicles, that range has to be between 17 and 19. So you can see that we're right within that range. And finally, the ratio of D90 to D10, that is really an estimate of the variability in the size of those grains. So you want them to be quite consistently sized. So the industry standard is less than 3.5 and we got 3.16. So that leads to more consistent performance of your battery if you have a more regular shape of those grain sizes. So as you can see, all those parameters, the very important specific parameters for the spherical graphite, have been well and truly achieved in the processing of our graphite into spherical graphite. So where to from here? While we have a resource that's 8.5 million tonnes, which is quite a reasonable resource, we want to build on that. So we have the option to upgrade the amount of material that we can process. So how are we going to do that? Well, we have a number of prospects. One of those is a prospect called Lacroma, and that occurs in the northwest of our tenements. And the reason we want to go there is that there's a drill hole that was drilled that intersected 60 metres at 6.8% total graphitic carbon, which is quite a thick interval of graphite in the ground, and that occurs over an airborne electromagnetic anomaly. Now you can see in the image there, that multicoloured image, the red zones, and the red zones are where that airborne electromagnetic anomaly measures how conductive the ground is. And there's a 12-kilometre long anomaly where that drill hole occurs, which we think is all graphite. So we'll be drilling that in the last quarter of this year and hoping to start proving up additional resources at Lacroma that we can build into our Campoona Graphite Project. And finally, we have another project or prospect that we're very excited about, and that is the Sugarloaf prospect. Now this is adjacent to our currently planned processing facilities, so they're right next to the multi-purpose licenses that we have already been issued for establishing a processing facility for graphite, so they're right next to that. Now back in between 2011 and 2016, Archer Materials drilled across an airborne electromagnetic anomaly looking for crystalline graphite, and what they found was high grades of graphite, up to 25%, over thick intervals, over 50 meters thick, almost outcropping along a strike length of about 4 kilometers. So they looked at building this up as another potential resource for the Campoona Graphite project. But what they found was that it was microcrystalline graphite. Now, back when they were doing this, having a large flake size, so not microcrystalline, was very important to the economics of the project. But as graphite has been used more and more in the anodes of lithium-ion batteries, the very fine flake size, even a microcrystalline flake size, has become much more important. So we aim to start metallurgical test work to determine again if we can concentrate it up to those very high levels, and we'll also be starting a drilling program again in the last quarter of this year to start building up resources at Sugarloaf. And we have some more information that we'll add to that story very soon. So thanks for listening. Very excited about our graphite projects on the Eyre Peninsula for iTech Minerals, and please join us again soon for more information on this project. Thanks.